For centuries, fishermen along the shores of Peru noticed a recurring mystery. Every few years, the usually freezing coastal waters would turn strangely warm, and the massive schools of fish they relied on would suddenly disappear. Because this warming tended to peak in late December, they called it El Niño, the Christ child. It was a local name for what they thought was a local problem. We now see that this warming water is a global trigger. A single severe event can drain trillions of dollars from the global economy by disrupting everything from the price of grain to the stability of energy grids. This one pocket of shifting heat in the Pacific acts as a master switch, dictating the weather and the markets for the entire planet. Think of the Pacific Ocean like a giant kiddie pool. If you blow air steadily across the surface, the water reacts in a very specific way. Usually, strong winds blow from east to west. They push the warm surface water toward Asia, while cold, nutrient-rich water rises from the deep ocean near the Americas to take its place. During an El Niño, those winds weaken. Without that steady push, the warm water sloshes back toward the Americas. It forms a thick, warm layer that traps the cold water deep below the surface. In the opposite phase, La Niña, the winds go into overdrive. They shove an extreme amount of warm water toward Asia, allowing a massive column of freezing water to take over the eastern Pacific. When this much heat moves across the ocean, it changes the temperature of the air above it. That air then rises or sinks in new places, shifting the high and low pressure zones that govern global wind and rain. Mapping the movement of this heat allows us to see exactly how a calm, predictable season transitions into a global weather crisis. Before we learned how to monitor these shifts, they hit without warning. In 1982, an El Niño developed so fast it bypassed our limited sensors, eventually causing agricultural systems to fail on 5 continents. By 1997, a super event brought 10 times the usual rain to parts of South America. Families were forced onto floating platforms as entire neighborhoods disappeared under deep brown floodwaters. At the same time, the other side of the Pacific was bone dry. Indonesia suffered through a severe drought that led to massive wildfires, burying the region under choking smoke for months. That single 1997 cycle resulted in 21,000 deaths and $45 billion in infrastructure damage worldwide. When these violent swings occur without a clear warning, our cities and emergency networks simply are not built to withstand the pressure. The flooding left behind by these storms creates a secondary crisis. Stagnant water becomes a massive breeding ground for mosquitoes, causing sudden spikes in malaria and dengue fever cases. In drought-stricken areas, shrinking rivers force people to use contaminated water sources, which leads to rapid outbreaks of cholera. By the time the 2015 event peaked, 60 million people were facing food shortages because their local harvests had completely withered in the heat. These localized failures quickly turn into trade wars. As countries move to protect their own food supplies, prices rise everywhere, and international supply lines begin to freeze. Today, global warming is adding fuel to this cycle. Higher baseline temperatures mean the ocean has more energy to move, making these sloshing events more frequent and more intense. An intensified Pacific cycle is no longer just a weather event. It is a direct threat to global economic stability and human life. We have shifted from being victims of the ocean to active observers. We now maintain a real-time map of the Pacific, using a high-tech network of satellites and deep-sea buoys. This data is fed into artificial intelligence models, looking for patterns the human eye might miss. Scientists discovered that the ocean surface gives away its next move through tiny changes in pressure and depth long before the temperature actually spikes. By identifying these whispers, AI can now accurately predict a major shift 16 months before it happens. This foresight allows governments to act before the rain or the heat arrives. Emergency budgets are unlocked and aid is positioned while the weather is still calm. It also changes how we manage our physical world. Dams can begin discharging water early to make room for floods, and farmers can plant crops that thrive in the specific conditions the models have forecast. We still cannot stop the Pacific from sloshing, but by identifying the signals that lead to the shift, we have gained the power to prepare for tomorrow instead of reacting to today.